Hey guys, lesson 3.4, solving ax plus b equals c. Here we can see our learning target. Equivalent expressions as we are solving. As always, you should attempt to work through each example before you would continue the movie, so you can go ahead and press pause for extra time to work an example or to write something down. Well, let's dive in. Go ahead and take a look at the warm-up today. I am not going to reveal the answer for the warm-up. This is something that we will talk about in class. Please press pause, take a moment to work through the warm-up. So the first thing that we need to talk about, since we are solving ax plus b equals c, are equations of this form. So I have given you 6 different equations. Your task right now is to decide if these equations represent the form ax plus b equals c. You should explain, and I guess maybe in your head, or be able to explain, give a reason for why you think it is or why you think it isn't. Please press pause and work through these examples now. If we take a look at equation A, this may not look like it is of this form because of this subtraction. However, if we remember that a subtraction is really a plus negative, this is of the form where the A is a 4, B is negative 8, and C is 10. In this case, our x is the variable k. If we take a look at B, taking a look at this is actually not in the form ax plus b equals c. However, we could easily simplify by combining like terms, and it would be of the form ax plus b equals c. Equation C, yes, it is of the form. Here our A, our coefficient, is equal to 3/4. Our B, the constant term, is equal to -1. And C, the value on the other side of the equation, is 14. D, again, yes, this is of the form ax plus b equals c. A is equal to -1/2. Our coefficient, our constant term B, in this case, is equal to 5. And it is equivalent or equal to -21. E is also of the form ax plus b equals c. This time, actually, if we take a look, the coefficient on G, this one is a little goofy, but we know that dividing by 2 is the same as multiplying by 1/2. So this minus G over 2 is actually giving us a coefficient of -1/2. Our B, our constant term, is 6, and it all has a value of 10. And finally, in F, this again is of the form ax plus b equals c. In this case, our A coefficient has a value of -2. Our constant term has a value of 8, and everything together is a value of 9. This type of equation you will become very familiar with over the next assignment. Equals 7. So if we follow the directions, first it tells us to, of course, write the equation. I would go one step further and say that we should change this to a plus -53. That always helps us just remember where a negative is and where we want to make sure that we include the negative. As we go ahead and continue here, it says add blank to each side. If I want a hint on what I should be adding on each side, I can go ahead and look at the next step of the equation. On the left side of the equation, the only thing remaining is the -3/2. So we always go ahead and eliminate the constant term by adding the opposite to each side. So in this case, we would want to add 53 to each side. We would want to go ahead and add 53 to each side. So we'll do that. Whoa, that one got a little crazy. 53 to each side. On this side, we'll see opposites zeroing out. On this side, 7 plus 53 makes 60. So we're just simplifying by combining our like terms. Moving on, it requests that we multiply each side by the reciprocal of negative 3 halves. The reciprocal of a negative is always a negative, and we want to go ahead and turn that fraction upside down. This, remember, will give us factors that will go ahead and cancel out for us. So if we take a look at the left side, the numerator has a factor of 2, as does the denominator. So we can simplify 2 over 2 to make a 1. The numerator also has a factor of a 3, as well the denominator is a factor of 3, so we can simplify that out and get a 1. Taking a look on the right side, when we multiply negative 2/3 times 60, here we had negative times a negative became a positive, so we were left with just x. We know what is going to be a negative. A negative times a positive is always a negative. Before we multiply, 3 has a factor of 3, and so does 60. 60 divided by 3 gives us a 20. So if we multiply through 2 times 20, we will see that x equals negative 40. We can check to see that x equals negative 40 is a solution by substituting for x in the original equation. Taking a look at an additional example, we can solve and check the following equation. Go ahead and press pause, make an attempt at this on your own if you feel like you're ready, or you can slowly watch each step show up. Here are our equation, 4k minus 8 equals 10. We can see this really is a plus negative 8. We always want to start by adding the opposite of the constant term to both sides to eliminate the constant term, so we can actually see the addition of the same value on both sides. The next step is to just simplify. Here we're combining our like terms. Next we can multiply by the reciprocal of the coefficient, or divide by the coefficient here, the coefficient being of course 4, for 4 times k. If we divide both sides by the coefficient to eliminate the coefficient, we'll see some common factors. For example, the left side of the equation has a 4 factor in the numerator and the denominator, and on the right side we have a 2 factor in both the numerator and the denominator. So we are left with 1k equals 9 over 2, or 4.5. Always a good idea to go back and check your answer, which we see happening on the left here. Just testing that out, does it actually make a match? And in this case it does. 10 equals 10. You should try the next example on your own by pressing pause and then advancing the video. So without further ado, our next example. First things first, we would like to eliminate this coefficient, this constant term, minus 1, or really a plus negative 1, by adding its opposite, positive 1, to both sides. Simplifying, combining our like terms results in the equation, the equivalent equation, 15 equals 3/4 m. Step 2 then is to eliminate the coefficient by multiplying by the reciprocal or dividing. In this case with the fraction, it makes the most sense to multiply by the reciprocal. So we are multiplying both sides by 4/3. We're going to find our common factors. In this case, on the left side, both 3 and 15 have a common factor of 3. On the right side, 4 and 4 have a common factor of 4. 3 and 3 have a common factor of 3, resulting in 4 times 5 on the left, and all 1s on the right side times m, or 20 equals m. Again, your next example you should try to work through on your own. Step 1 here, eliminate the constant term by adding the opposite. Here our constant is an 8, so we will begin by adding negative 8 to both sides. If we combine like terms on each side of the equation, this will result in negative 2x equals 1. From here, we'll work on step 2, eliminating the coefficient by multiplying by the reciprocal, or in this case, dividing. We'll divide by -2, finding our common factors. -2 in the numerator and the denominator, -2 factor on the left side, resulting in 1x equals -1/2, or -1/2. If we check our answer back to the original equation, trying out a -1/2 for x, we come up with 9 equals 9, so we know we have the right answer. That's everything. Be ready to ask your questions or email Mrs. Reba with your questions. We'll see you next week.